Parallelograms.
Yeah, four sides.
That's
Two
quadrilaterals.
congruent.
Two parallel.
Congruent.
Okay, I'm not gonna write them all, but what do we know? Opposite sides are parallel. What else?
Adds up to 360.
Oh, that's any quadrilateral. What's specific to a parallelogram? We're looking for what do we know specifically about parallelograms?
Opposite
The
angles are
diagonals.
congruent.
Opposite angles are congruent.
Isn't like the diagonals are the same?
I forgot the word.
No, they're not.
Complementary.
Diagonals are not the same because it could look like this.
Consecutive
Short,
angles
long.
are supplementary.
Consecutive angles are supplementary, that's 3. Opposite sides are
Congruent.
congruent. These two. And diagonals bisect. That doesn't mean they're congruent to each other, that means they're cut in half. So this part is congruent to that part, and this part is congruent to that part. Okay, that's just parallelograms. That's just one thing. We did talk about that the most, probably parallelograms, but what makes a rectangle a rectangle?
The 90 degree.
90 degree, yeah, 4 congruent angles, 90 degree angles. Also, we learned that rectangles have congruent diagonals. Unlike parallelograms, rectangles have congruent diagonals because it's like twins. Rhombuses, what makes a rhombus a rhombus?
One pair of parallels.
No. Why does nobody know what a rhombus is? I don't know.
I know either.
It's like that thingy.
No.
Oh,
Oh, wait,
congruent
wait.
sides.
4 congruent sides, that's it. A rhombus has 4 equal sides. Okay, usually looks like this. 1, 2, 3, 4. Okay, and what we learned about a rhombus's diagonals were they're perpendicular. I didn't draw very well. They're perpendicular. They are not congruent, but they also bisect the angles. Okay, and so not only is this true about the rhombus, but everything that's true about a parallelogram is true about the rhombus. So that makes a lot of things true about a rhombus. What makes so a square is both a rectangle and a rhombus, so all of the above applies to a square. What do we learn about trapezoids?
One pair.
One pair, that's the definition of trapezoid. If the legs are congruent, hush. If the legs are congruent, what's that called? Isosceles, and like these angles are congruent, these angles are congruent. These two angles add up to 180 because they're like same side interior. Diagonals are congruent because everything is like perfect. But on a normal rhombus, that's not true. You don't really know that much on that. All you know is parallel, and these two add up to 180. These two add up to 180 also. Okay, and then kite, what do we know about kites?
It's the same like the
They look like a
They have opposite angles.
They have one.
These two are congruent, these two are not. See how this one's a lot bigger than that one? Diagonals are perpendicular, kind of like a rhombus.
The top two and the bottom two sides are congruent.
These are bisected angles.
Complementary.
What else? Yeah, these two kites, that makes these, all the triangles that look the same are the same. Okay, anyway, there's a lot of stuff. That's about 60%, 50% maybe what we talked about.
So if I know that, I might get a 60 on the math test.
That's the goal, yeah.
Okay.
Number 1, so our options are, in the directions it says list all that apply. Parallelogram P, rectangle RE, rhombus RH, square S, trapezoid T, isosceles trapezoid, or kite. So we got 7 options. A lot of these problems will have multiple answers, most of them do. But we gotta list all that apply. So which of those shapes, which of those quadrilaterals has no sides parallel? Kite. Trapezoid has 1 pair of parallel sides, right? So just kite. So 1 actually does only have 1 answer.
Everything else I just do.
Well, almost everything, not everything. So like two evens that have one answer. Okay, number 3, two pairs of opposite sides, or in other words, both pairs of opposite sides are parallel.
Square, rectangle.
That's like the definition of a what? Both pairs of opposite sides are parallel.
Parallel.
It's a parallelogram. But what else is a parallelogram?
Rectangle.
Rectangles are, so
Square.
RE, squared,
Rhombus.
and a rhombus, RH.
It's gonna be a.
So if it's true for a parallelogram, it's going to be true for rectangle, rhombus, and square because those are parallelograms. Anything else with both pairs of opposite sides parallel? No. The answer is no.
No.
I saw a trapezoid only has one pair of parallel sides, so it doesn't work. Number 5. Two pairs of opposite sides are congruent. Two pairs opposite sides.
So you got
Is
square,
that a rectangle?
you got rhombus,
Okay.
you got.
That rhombus has all 4 sides that are congruent. What's it if only the opposite sides are congruent?
Rectangle.
Okay, that was one of the things.
Oh,
we-
wait, you got height?
Parallel.
No,
Wait,
that's
wait.
one of the things we said for parallelogram. Remember, that was one of the 5. Opposite sides are congruent
Oh, it's opposite.
in a parallelogram. Not all sides are congruent, just opposite sides are congruent. So if it's true for a parallelogram, it's true for rectangle, rhombus, square. Anything else have opposite sides congruent? Trapezoid, isosceles trapezoid has one pair of opposite sides congruent, but not 2 pairs. Number 7, all angles are congruent in a what?
Square.
Square,
Rectangle.
rectangle. That's like the definition of rectangle, kind of.
Oh, rhombus.
Rhombus has different angles, like these 2 are different than these 2. And just like all
I
parallelograms.
thought it said size. One day.
Okay, number 9, the diagonals bisect each other. That happens in a what? No,
Rhombus.
no,
Trapezoid?
no.
Oh.
Okay, that was one of the 5 for parallelogram. Diagonals bisect each other. So if it's true for parallelogram, it's true for rectangle, rhombus.
So I was right.
Number 11, diagonals are perpendicular.
That's a trapezoid?
No.
What?
Let's go back to my drawing at the beginning. Diagonals are perpendicular in a
Rhombus.
rhombus. And if it's true for a rhombus, what else is it true for?
Square.
Square and
Triangle.
kite. So rhombus, square, and kite.
Who
Yeah,
said
this first part is kind of hard. There's a lot. Okay,
That is a lot.
13. No, there's some of it. So this part's a little bit weird. They say describe how to check that each figure is a described type of quadrilateral using only a compass to measure the lengths. So basically, they're saying if we could only measure lengths, how could we prove this is a blank? So on 13, what needs to be equal length for that to be a parallelogram? What would the opposite sides? So we need to say that AB would need to equal CD and AD would need to equal BC.
Is this the drawing test?
Oh, who knows? I don't know. Not exactly in this form, but but you do need no opposite sides are congruent in parallelogram. Number 11. So what needs to be equal in length for that to be a rhombus?
The diagonal.
All the sides. That's the definition of a rhombus. All sides are congruent. So AB would need equal BC, would need equal CD, would need equal AD.
Mr. Jordan,
Hmm.
Wait, why aren't we putting like a line above them?
Okay, because when you don't put a line, you're talking about the length
Oh,
of
the
the
length.
segment.
whoa, 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 whoa.
Okay, 17. What needs to be true for that to be a square?
All the diagonals need to be the same.
On the angle.
All sides need to be the same.
Okay, so we can't measure angles. We can only measure side lengths for this
I know.
section. The sides need to be the same. That makes it a rhombus. So that's part of it. So we kind of repeat 15 on this.
Don't the diagonals need to be the same thing?
Yeah.
Maybe.
So all the sides being equal makes it a rhombus like number 15. But you also need it to be a rectangle. And for it to be a rectangle, the diagonals would have to be the same. So
AC equals BC.
AC equals BD. Also needs to be true.
Is square like the only one that don't have like two things?
Yeah, basically. Well, hang on, let me look at this. 16 is kind of like that, because for a rectangle, for it to be a rectangle, the opposite sides have to be equal and the diagonals have to be equal. 18, you guys know it has to be equal in a kite, probably.
The, on 16, the opposite sides have to.
Opposite sides have to be congruent and diagonals have to be congruent for it to be a rectangle. For an isosceles trapezoid, the diagonals should be equal and the two legs should be equal.
Legit.
Spanish for milk.
For isosceles trapezoid, you said diagonals and legs.
Huh?
You said isosceles trapezoid, the legs and the.
Yeah, the legs are the same length. That's the definition of isosceles. And then the
Bailan.
diagonals. He's bilingual.
Oh, me too. Hola.
Hola.
Oh, that's crazy. Almost down.
Okay, 19. Do you guys want to do all the odds today?
Yes.
No, because then tomorrow
Wait.
we'll need a refresher.
No,
You know
if we do all the
Yeah.
odds today, we should do all the events
No,
tomorrow.
all the
That's-
odds.
oh, no.
Consider. I thought we saved the rest of the odds tomorrow.
I said we
By
do
the time
half
we get
today,
to-
half tomorrow.
Well,
Because then by the time we get to tomorrow, I might forget.
I'm not moving the test, obviously.
Alright, half today, half tomorrow.
I'm a drooling idiot. Okay, 19. What can you conclude about the diagonals in each type of quadrilateral? What do we know about a rectangle diagonals? They're congruent. And in a rectangle, they're congruent. But what do we know about parallelograms in general? In parallelograms, they bisect each other. So that would be true in a rectangle as well. "21. State another name." Are you guys done with 19? State another name for the polygon. Equiangular rhombus. What's equiangular mean?
It's all equal.
Equal what?
Angles.
Angles. So a rhombus with equal angles is a square. It's got equal sides, equal angles, that's a square.
Alright, we done now?
No.
So are we just doing all the odds?
Let's go. maybe 31.
We're not doing 25.
I'd rather get, yeah, most of it done.
That means we have a lot of homework tonight.
We're doing the rest of it tomorrow.
Yeah,
Oh, I
So-
forget.
and then that's not
No.
until Friday.
What if you,
It's Wednesday.
oh, fuck.
Except for Emily's too.
Well, honestly, I'd rather go to
It's actually due by the end of the hour.
Okay, 23. Find the measure of an interior angle of a regular polygon. Okay, you will need to know this for the test, by the way. How do we find what all the angles add up to in a polygon? No, that's a
Oh,
quadrilateral.
it's like 360's four sides, right?
360 is for quadrilateral,
And
yes.
it's like you from that down, you could go times something.
Okay, nobody remember?
560? 180? Oh,
You times it by
You
something.
times it by,
The number of sides.
Y'all are trying too hard.
Okay, n minus 2 times 180 gives you all the angles, what all the angles add up to in a shape. But how do we find just one angle in the shape?
divided by,
Divided by two.
Divide by the number of angles.
stop.
Okay, so on 23, it's a nonagon. How many sides does a nonagon have?
No.
9. So you do 9 minus 2 times 180. That gives you all the angles together. And you divide that by the 9 angles. That's going to equal like 7 times 20 basically. 140.
Have you seen Tangled?
You're so wrong.
Okay. For 25, I know I did an assignment, but let me see if you guys can figure this out.
What the heck is
What
that?
happens to the angles as you add more and more sides as the,
The angles get smaller.
no?
The angles get bigger.
Oh, the angles
I got equal 180.
Yeah. What's happening to the angles here?
Getting bigger.
They're getting bigger. They're approaching, as the number of sides approaches infinity, like it's bigger, bigger, bigger. Like if we had like 1,000 sides, it might look like
A circle.
this. But what are these angles approaching?
Whoa, 360.
180. It's approaching a straight angle, right?
Who's it?
Okay, and what is the shape becoming?
A line.
Wait,
Circle.
And then.
So a circle is like a polygon with an infinite number of sides. Mind blowing. Okay, we kind of just did 25, but that's okay. We're skipping over 27.
Wait, is that per grade?
Nah, I did right.
That was just
We did do 25, but I said skip it, so we're not gonna get
That
to
was
it.
just a little discussion. What did you think?
Who all in here goes
Kixie.
Okay. So 27, the directions say use parallelogram PQRS for 27 through 29. So you can assume that's a parallelogram. Therefore, segment QR is congruent to what? Focus. What's QR congruent to on 27?
Yes.
PS. Angle QT equal, or not QT, or not angle, just QT length equals what?
QT equals ST.
Yes, TS, ST. Yeah, diagonals bisect each other. That means they're cut into two equal. That doesn't mean their diagonals are congruent though. Okay, C, angle PQR is congruent to,
RSP.
yeah, the opposite angles. QPR is congruent to RSP, yes.
cherry pizza.
Okay, D, angle QPS plus what equals 180?
QRS.
PSR,
Yeah, why is it PSR?
because it's that, yeah.
Okay, they call it consecutive angles. So these two angles add up to 180, or these two angles add up to 180. So, yeah, we can say RSP again. Or PSR. That's fine. Okay. 29. This one is a bit more challenging. So we're on 29, we're still supposed to be using that picture from the last problem. So it's QRSP.
What are your thoughts on furries?
Okay, so it says QP, nope, I'm looking in the wrong spot. QP is 3x minus 1. And RS is 3y plus 5. Okay, what do we know about these two?
They're congruent.
Those two are equal or congruent. And QT is 4y plus 1. And the other one is 2x plus 7. Okay, what do we know about these two?
They're equal.
They're also equal, because diagonals bisect. So 3x minus 1 should equal 2y, or 3y plus 5.
Oh,
And,
Liz.
can we solve that, by the way?
No.
No. And 4y plus 1 equals 2x plus 7. Actually, might switch those two.
Is this substitution or is it the other one?
Oh, this is on the toast, right?
Who can say?
You can say
This could
no.
be.
And then you'd be the bestest person.
All right. Yeah, this is a system of equations where you have to use either substitution or elimination. Probably
Can we substitute?
elimination would be easier. To use substitution, you have to get an equation where it says x equals or y equals. So you'd have to get x by itself, which is possible. You guys want to do substitution instead of
No.
elimination?
I need to learn elimination.
I would probably do elimination. One of the challenges with elimination here is stuff isn't lined up very well, so I would probably change it to standard form. Like I would subtract 3y over to this side and add the 1 back to this side. So it'd be 3x minus 3y equals 6. You guys see where I got that?
Yeah.
And what would the other equation become if I did the same thing? 2x, what?
Minus 4y.
Minus 4y equals
Negative 6.
negative 6. Shh. Okay. You guys know what we did next?
Yep.
At this point?
Do X minus negative Y.
Okay. Elimination is where you add the lines together to try to eliminate the x's or the y's. If I added the lines together, would the x's or y's go away?
No.
No.
You have to.
Don't you have to like
Okay, what do 3x and 2x both go into? 6. What would I have to multiply this one by? Okay, I'm going to multiply the bottom by negative 3, so it's a negative 6x. So the top times 2 becomes this. The bottom times negative 3 becomes that.
I get it. I actually understand that.
That's good because we're doing this again next year in algebra. This algebra. This is like the
See,
test.
I get it, but do I like it?
That's the test this year that everybody just like did really well
I
really
suck
fun.
on
at
in algebra 2.
That means that this stuff is easy. No, it's not.
Well, you guys have done it in algebra 1, so by the time you get to algebra 2, it kind of gets easier.
I don't like this game.
Anyways, when we add the lines together, what's gonna happen to the x's? They go away. Negative 6y plus 12y. 12 plus 18. So y is 5. How do I find x?
Plug Y in.
Plug y in. So if I put right there, 3 times 5 is 15. So 3x minus 15 equals 6.
Such a problem.
I know, I really ran around.
Uh-oh.
So x is 7.
Oh, God.
Now, unfortunately, this is not
The
not the answer.
Of course it's not.
Okay, the question was, A, what is QP, length of QP, and B, what is QS? Shh, hush. So how could I find the length of QP?
Plug it in.
Plug it in. I got X is 7. Actually, we could have plugged in Y over here. We didn't really need X. But if I plug in X, 3 times 7 minus 1,
27, 28. No, 20, I'm at 20. I'm at 20. Because it's, yeah, yes, I know it's wrong.
okay, and B is asking for QS. So how could I do QS?
Good question.
plug Y and
Okay, 4 times 5 plus 1.
21.
So if this is 21, guess what that is?
It's gonna be
21.
21
So
plus
you-
21 is 77.
Bro, what?
Close enough.
That's some Roman style math there.
Yo.
Hey.
Speaking of the country Rome, or the city Rome.
Yeah. No,
Okay,
no,
we stop?
Don't we still?
All right, we'll stop there. We'll stop there.
That's it for the word.
You know
I'll go back tomorrow.
You know why? You wanna know?
We got over half of it done.